Okay, this is the video to go with day 2 of 4.7 trigonometric inverses. We probably went over a lot of this in class, but this is a supplement then to what we did so that you can go back over some of these concepts. Okay, on this first screen we're seeing that we're going to use a trig function to write theta as a function of x. So what that means is that you want to start out with theta, and I want theta to be equal to something. Well, theta is an angle, so this is going to be an arc. So it'll be an inverse statement that I'm going to write. And the given information is opposite over adjacent, which would be arc tangent. And then I would write the ratio, which is opposite over adjacent, which would be theta is equal to arc tangent of 8 over x. I'm going to do this here. I'm not going to find the third side, I'm just going to use what's here. So theta would be equal to, this is adjacent over hypotenuse, even though I don't have the right angles written in here, that's this. So adjacent and hypotenuse is cosine. So the arc cosine, remember that the angle is equal to the inverse of the ratio. So this would be 5 over x. And those are the two statements. This goes with the top, this one goes with the bottom. Okay, another example would be if I'm given the same kind of triangle, this time opposite and hypotenuse, right? So immediately I can write the inverse sine, because this is opposite and this is hypotenuse. So this would just be 5 over x. So I don't have to do anything to write sine inverse, arc sine, because that is what I'm given on the triangle. It says here, though, find the third side. So anytime you find the third side of a right triangle, you're using the Pythagorean theorem, right? And so this side right here would be equal to the hypotenuse squared minus the other leg squared, right? This side right here. Let's call it side squared. But I don't want the side squared, I want the side. So the side is going to be equal to x squared, the square root of x squared minus 25. So this is the third side, is this ratio right here. All right, so cosine, you remember, is adjacent over hypotenuse. Well, the side adjacent is this x squared, the square root of x squared minus 25. Leave it, don't try to simplify it, over the hypotenuse, which is x. Tangent is opposite over adjacent, so I would have 5 over this side that I found. Okay, so I don't know what x is, I don't know what theta is, so I have to leave those as variables in my functions here. Okay, we're going to try it again. I've been given a different function. Notice that I have been given opposite and hypotenuse again. So that is the inverse sign. So that's going to be x plus 1 over 3. It says find the third side. So the third side is the square root, the hypotenuse squared, 3 squared, minus the leg over here squared. Now I could multiply all of that out. It's not a hard thing to multiply out, but I don't need to. It doesn't save me anything. Okay, so this is the third side. So to find cosine, I would have the square root of 9 minus x plus 1 quantity squared over the hypotenuse, which is 3. And then the tangent would be x plus 1, opposite over adjacent, and that's 9 minus x plus 1 quantity squared. And I found this, remember, this is the Pythagorean theorem. Okay, these are the inverse trig properties for composition functions. Remember that a composition function would be like if you had f of g of x, right? You would substitute g of x for the x in the f function. Well, these are trig composition functions. So what you see here is you have the sine of the inverse sine of x, and the x right here, this x, represents a ratio, right? And then sine inverse of x represents an angle, usually theta. Okay, so basically you have the sine of an angle. The angle is an inverse function of a ratio, so that's the composition. The interesting property here, though, is if you have sine on the outside, or cosine or tangent, not arc, but just the function. If you take the sine of the inverse sine, you end up with just the x. If you take the cosine of the arc cosine of x, you end up with the ratio. And the tangent of the arc tangent of x is equal to x. Now, notice the domains and ranges here. The domain for the inverse function would be, the domain needs to be from -1 to 1, and the range is from -π/2 to π/2, right? And this is for the domain and range for the inverse function. Same here and same here. These are for the inverse functions. Okay, so domain and range. Okay, here are some examples of the properties that we just did. Notice here that you have the tangent on the outside here, just like the properties. So if you take the tangent of the arc tangent, notice the tangents, I don't have like a different one here, they're both tangents, of -5, then I can say that this would equal -5. So this is the x right here. So as long as the tangent of the arc tangent, I'm good, I've got -5. Now this one, notice that it starts with an arc and has a sine. That's not the property. This is not the property. Okay, so I'm actually going to have to figure this out bit by bit. All right, if I take the sine of 5π/3, that is in the fourth quadrant where sine is negative, so the ratio will be negative. The sine of π/3 is square root of 3/2. So I write that in there. Well, what is the arc sine of negative? Well, I know it's going to be a negative angle, right, because this is negative, and over that would be π/3. So this is -π/3. So the arc sine of a ratio is an angle. So think about this outside one will net an angle. Okay, now here we have a slightly different thing, because this is saying right here that this is pi, and pi is about 3.14. However, this is not an angle, it's a ratio. And the ratio 3.14 is not in the domain of sine, of inverse sine. The domain is from -1 to 1. Right? So this is undefined. It cannot exist. It can't exist because this number is too big. Right? So the answer is not pi, it's actually undefined because this is too big. Too big. And they didn't realize or remember that this is a ratio, not an angle. Not an angle. Okay, these are a couple more examples, and once again I can't use the property because this starts out with arc cosine. So I start with the innermost and I say, where is 7π/2? Well, I'm going to use the unit circle to help me. All the way around is 4π/2, right? All the way around again would be 8π/2. This is 7π, so it's going to end up right here. And that would be the cosine of 3π/2, right? Would be the same coterminal angle. So that would be 0. So this whole thing is 0. So the arc cosine of 0, right? Where is the cosine equal to 0? Well, the cosine is equal to 0. You might be tempted to say here, but it's actually here, because this is the domain of arc cosine. So it's going to be π/2. You may start to see a pattern. Right here you see this is π/2, 7π/2, it's still over 2, right? So the arc cosine will be π/2, or within the inverse. All right, on E we have, once again, we start out with an arc cosine. So this is also not the property. It's also not the property. So I can't just write 3π/4 over here. But I can find the tangent of 3π/4. Tangent is negative in the second quadrant, so this would actually be -1. Right? And then I want to take the arc cosine of -1. And so once again, looking here, where is cosine equal to -1? That's over here, right, at pi. So this is just pi. Then we move into some expressions that are not on the unit circle. So for instance, if I have the secant of arcsine 3/5, 3/5, the ratio 3/5 is not on the unit circle. The only ones that are on the unit circle are things like square root of 2 over 2, 1/2, square root of 3, 1, 0, all those regular values. 3/5 is not there. So what this is actually telling me right here is to draw a triangle, sketch a triangle. In fact, I'm going to say sketch a triangle here. Okay, and not just any triangle, but a right triangle. All right, so I'm going to start off with that. And then this is a ratio. 3/5 is a ratio, right, of sine, arcsine, which means arcsine or sine is just opposite over hypotenuse. So here's opposite, and here's hypotenuse. So it's going to be 3 over 5. Now some of you are going to recognize that this is a Pythagorean triple, and I can already find the third side. I can use the Pythagorean theorem if I can't remember, but this is a Pythagorean triple, so this is 4. All right, so to find the exact value of this expression, you sketch a triangle, you write in the ratio, you find the third side, and then you look at this outside here. I'm trying to find the secant of theta, right? Theta is the arcsine of 3/5. So the secant would be 1 over cosine, right? And cosine is 4/5, so this is going to be 5/4. So there's a bit involved here, but you recognize it's not on the unit circle. It's not on the unit circle. This is a ratio. You use the ratio to sketch a triangle right here. Find the third side, and then write the ratio, and that's how you get the answer. Okay, let's do a couple more, and this will be it for the lesson. All right, so once again, I have a tangent of an arc cosine. This is still not the property because it would need to be tangent of the arc tangent, and it's not. Same here, tangent of the arc cosine. All right, so what I'm going to do is I'm going to move this up a little bit. Okay, I'm going to notice that the 12 over 13 is not on the unit circle. And so because it's not on the unit circle, I'm going to draw a triangle. So I draw a right triangle, and I look at cosine. Cosine is adjacent over hypotenuse. So I'm going to write the ratio onto the triangle. Now I need to find the third side using the Pythagorean theorem, or if you know that this is a Pythagorean triple, but it will be the square root of 13 squared minus 12 squared, which will be 169 minus 144, which is 25. So this side over here will be 5. All right? And then, so that, drawing the triangle came out of this part right here, the arc cosine. Now I want to find the tangent of theta. Now that I have my triangle, use the triangle. Tangent is opposite over adjacent, which is 5 over 12. So the answer, the tangent of the arc cosine of 12/13 is 5/12. Okay, and we'll do this last one. Down here, I have the tangent of the arc cosine of x over 5. All right, so once again, I'm going to sketch a little right triangle, put in theta, just, a little ubiquitous right triangle. Cosine, remember, is adjacent over hypotenuse, so this will be x and a 5, right? Find the third side. Using the Pythagorean theorem would be the hypotenuse squared minus the leg squared. Another way to write that is 25 minus x squared. Then the final thing is to find the tangent of theta from the triangle. Tangent is opposite over adjacent. This is opposite, adjacent. So this will be the ratio of the square root of 25 minus x squared over x. And that's what goes here in the blank. The square root of 25 minus x squared over x. And those are the types of problems that we're using with inverses. And in class, we're going to continue to practice using the whiteboards, finding just your basic unit using the values off the unit circle, finding the arc cosine of 1/2 and the arc tangent of -1, and being able to pull those angles out of your brain without having to look at a unit circle. All right, so I will see you in class.